Howdy. Oh man, I just finished my bunny rabbit. So nutrition facts: 140 calorie and 5 servings per container. Uh, servings isn't necessarily sittings, is it? Yeah, how many calories is that? Well, let's see. 140 calories, and it says 28 grams. So I could just divide those, right? I could 140 divided by 28. Hey, man, 5 calories per 1 gram. That's not too bad. Doesn't sound bad. I can eat all of that, man. Wait a minute, though. 5 doesn't sound like much. What do they mean by calories? Keep in mind, calories is actually a sneaky term because 1 calorie with a lowercase c is the amount of energy it takes to raise 1 gram of water, and we want it to raise by 1 degree Celsius. Alright? But this 1 calorie is 1,000 little calories. So what my chocolate here would actually be 5,000 little calories, which is enough energy to take 1 gram of water, 1 milliliter of water, since water is 1 gram per milliliter for its density. Take a milliliter of water and raise its temperature by 5,000 degrees. Ooh, that's a lot of energy. How do they even find this energy? Let's figure that out. Well, it turns out there's 2 ways of really finding energy. And the first way in this calorimetry, they use a bomb calorimeter. Oh man, that sounds awesome, right? You push a button, there's a big explosion, you measure the energy. Yeah, sort of. It's a box with a little wire that has an ignition source. Okay? And in this box, we have water. And hanging down, suspended in this water, is a sphere. And in that sphere, we put a lot of pure oxygen. And we run down our ignition source so we can run a spark. And then we put our food. And so I put my little piece of chocolate in there, and I hit the spark. What's going to go on at that point is the food's going to burn up, but it's in this metal cylinder. And metal cylinder will transfer its energy out to the water. And if I know how many grams of water I have, and I put a thermometer in here and measure the change in the temperature, then remember, a calorie, 1 calorie equals 1 gram of water by 1 degree C. I could measure how many calories. Now, in actuality, it depends on, this metal piece might not get the same temperature as the water. You got to remember there's a difference between heat and temperature. So heat is our mass times the specific heat, which depends on what it's made for. Now for water, it's 1 calorie for 1 gram. All right, so this is grams, and this would be in calories over grams times temperature. All right, and then I've got my change in temperature. So my temperature final minus my temp initial. how much did the temperature go up. All right. Now, we're also going to be transferring the heat, but whatever heat is lost by my food is going to go to my metal shell, and they use metal so that it will eventually transfer all its heat out to the outside. And so all of this goes to my water. So whatever heat is lost is equal to the heat that's gained. So if I measure the heat that's gained, I'd figure out how much heat was lost and how many calories are in this. Now, since it's a big insulated box so that there's no transfer of energy and no heat from the outside environment to the inside or from the inside to the outside, then all of our change in heat came from our bomb being set off, which you don't even get a thud. You push a button and the temperature slowly goes up, and that's it. Whew, that's boring. Sometimes low tech is more fun. All right, and so it turns out we can apply the same principle, but taking a Coke can and we put in some water and a thermometer, which just happens to fit in the lid of a Coke can, and we're going to put our food underneath it and set it on fire. And our food will heat up the can, which will heat up the water. And if we know how many grams of water, we can measure how many calories was transferred to the water. And so this works great if you've got a food that stays lit and burns really well. Chocolate, not so much. There's way too much water in it. So we need something that we could light. Peanuts work great, and I'm going to link a video where they actually did this experiment with peanuts and with the peanut, and you'll be able to find that the data off of the video that you'll need to complete today's lab. All right, the pre-lab I went ahead and took care of. What the pre-lab normally do is have you bring in different foods, and we try different foods. And if we know how many grams that we start with, then we can end up getting calories. That's not very good per gram. We want to get calories per gram of our food. And this is a very helpful way of measuring this. Peanuts work great, but there's too many people with peanut allergies, and even as we burn them, that can really cause people just walking by with problems. Doritos work okay. We've had great success with some Cheerios work okay. Problem is, a lot of fat tends to drip down, or you get a big flame, and some of the flame is lost. And then you get a lot of carbon scorching on your can that eventually impedes the energy transfer. And then, of course, heat's going out in all directions, not just up. And so our numbers we get here are actually not very close to what they report for those. So they're not that great, but it's always reported as one of our favorite labs. And I would do this lab for you, but no. No, we'll link it right off of YouTube. We'll follow it, and it'll be pretty quick. Yeah, this was, as a student, one of my favorite labs. The question I always had was, when we did the peanut, is you have to get that lit, and the fact that you're going to light this with a match or something burning, I gave the professor a hard time. Isn't that going to throw off our numbers? Not realizing that our numbers are so far thrown off that it really doesn't matter. And the amount of energy that's released from a peanut burning is so much more than one match. So it just really wasn't significant to the overall error. This is a nice way of kind of not just figuring out which kind of foods burn, but how do they calculate these numbers? So we'll be playing with these calorimetry. We'll link that video, and you'll play with those calculations. They're not too difficult. So we'll see you on the next one.